All right, so we're going to talk about the Wronskian and linear dependence and linear independence. So you should have already seen the Wronskian. I think I probably assigned something. I haven't done my assignments yet as I'm making this video, but should have seen already at least a small version of it. But let's go ahead and talk about it in general. Okay, let's let f1 through fn be functions that are all n minus 1 times differentiable. Okay, so then the Wronskian is W f1 through fn. It's actually the determinant, okay, let me, of this matrix. So f1 through fn along the top row, f1 prime through fn prime along the second row. I guess you can see where it's going, I hope. And all the way down till you get to the n minus 1 differential derivative. Okay, a lot of times in books, they actually write it a little differently. It's still the determinant, but they just use a notation where instead of writing determinant, they just use lines here. Okay? I know. You know what? You don't know how long I spent confused on that. Okay, so that's why I'm telling you guys that. Of course, chances are you've probably checked out. You're not really looking at my videos right now. But for those of you that are, you're getting the benefit of the things that I've learned over the years that I wish I would have paid a little better attention to. Okay? So let's take our theorem that we want to talk about, the Wronskian. So let y1 through y sub n, okay, all solve y sub n minus 1 of x plus, sorry, that should have been y sub n of x. So we're bringing it back to our differential equation, plus p1 of x, y sub n minus 1 of x, plus all the way up to p sub n of x, y, let me write of x. Let me move that. Just give myself more space. So they all solve the homogeneous equation. We're talking about the set that's going to be our homogeneous equation, okay? Now, the idea is that we want to know, do we have all of them that we need to express any solution, okay? So we're going to take p1 of x, all of these Pn of x are all continuous on AB, okay? Then the following are equivalent, okay? 1, y1 through y sub n are linearly dependent on AB, okay? 2, the Wronskian of y1 through y sub n equals 0 for all points in AB, or 3, the Wronskian y1 through yn equals 0 for some point in AB. This is really powerful, okay? This is really powerful because what this says is that we don't have to look at all of them. We just have to look at some point where the Wronskian is 0, and if it happens somewhere, it's linearly dependent, okay? Now, even better, this gets even better. We could also write this as such. Okay, let me copy this. Let me do this in a different color. Let's do it in orange. Okay, so instead of writing linearly dependent, I could write linearly independent. And then if it's linearly independent, these should not equal 0. So if we do this like so, let me put primes on here. Okay, that's another way to express the same idea. If it's linearly independent, then the Wronskian, I'm sorry, if the set is linearly independent, then the Wronskian is non-zero everywhere, and it's also non-zero just somewhere. You just need it to be somewhere non-zero, and that's all you have to check. Okay, so let's do an example. Let's consider the homogeneous differential equation y to the fourth minus y equals 0. Okay, and we could solve this doing the same thing. Let's assume y equals e to the rt, or e to the rx. So that's going to leave us with, like, let's just take the solution. R to the fourth minus 1 equals 0. R squared minus 1. R squared plus 1 equals 0. So R plus 1, R minus 1, R squared plus 1 equals 0. So we get R equals -1, R equals 1, R equals plus or minus I. Okay, so our general solution is going to be C1 e to the x plus C2 e to the negative x plus these i's. That means we're going to have cosine and sine, right? Let's use A and B. Okay, let me make this a little smaller so that I can fit it on the page. Okay, so we're going to check the Wronskian for e to the x, e to the negative x, cosine x, sine of x. Okay, so Wronskian of these equals the determinants. Do I have space? Yes. Let me move this down. Okay, the determinant of e to the x, e to the negative x. Actually, sorry about that. Just want to format it a little better. E to the x, e to the negative x, cosine x, sine x. Take the derivative on the next line. So e to the x, negative e to the negative x, negative sine x, cosine x. Take the derivative again, e to the x, e to the negative x, negative cosine x, negative sine x. Take the derivative one more time, e to the x, negative e to the negative x. What's that? Negative sine, no, sine x, negative cosine x. Oh man, if I had to take the determinant of this, even with a computer algebra system, it's going to be a pain. But I don't have to. I just have to do it at some point, right? I have no, I really have no discontinuity, so I'm going to take it at 0, okay? So I'm going to do this at x equals 0. When I do this at x equals 0, I'm going to get, let me do without with just the lines, 1, 1, 1, 0, 1, negative 1, 0, 1, 1, 1, negative 1, 0, 1, negative 1, 0, negative 1. And I really don't care about you being able to take determinants in this course. I mean, I'm using them, but look at that. We have octave. Oh, let's see. Does it got to refresh? Connection lost, attempting to. What I hate about the iPad is that it doesn't connect so well. One more time. There it is. So my A, or let's call it W. There we go. W equals now 1, 1, 1, 0, colon, 1, negative 1, 0, 1, colon, 1, 1, negative 1, 0, colon, 1, negative 1, 0, negative 1. Oh, let's try that again. 1, 1, 1, 0, 1, negative 1, 0, 1, 1, 1, negative 1. Oh, there we go. I missed one. The last one. How did I miss the last one? I don't know. I'm a dork. Okay. Just make sure that's right. Okay, now I'm going to take the determinant of that. I think I used lowercase w. The determinant of that is negative 8. Make this a little smaller. Okay, so this is negative 8. So the Wronskian is non-zero at some point. So that means that my set is in fact linearly independent. All right. Whew. Okay, so just in case it's not clear, this is section 6.1. It's a pretty theory intense section, okay? All right, so, but the problems you can sort of see, this is the sort of problem you might have to do. You know, you can sort of see what they are, but this is a very theory dependent sort of section, okay? All right, I'll see you all in the next section. Peace.